In some problem, you can have a question that can come in form of a word problem. You can have a word problem questions instead of giving it like this form. They can bring it in the form of word problem to make it more interesting. So let's take a look at that. They said question 2. If the first term of an AP is minus 3, while its common difference is 5. Find the third term. If you look at this problem, you can see we are given the problem in form of a word problem. But it's very simple and straightforward. We follow the same process. We bring out the data, the given data, then we apply our formula. We said if the first term of an AP is a minus 3, remember we know that A is simply the first term, right? So the first term is given as a minus 3, while its common difference is 5, meaning of D equal to 5. They now said find the third term. If I ask you now, how can we write out the third term? Who can remind us? Yeah, exactly. So if I want to write the third term, it's nothing but A plus 2D, right? So now let's just apply the formula, meaning find the third terms. It means when the number of terms equal to 3. I can just apply the formula, which is Tn is equal to A plus n minus 1D. So now let's input the data one after the other. The number of terms that we have is given as 3. That means that we have T3 is equal to, our first term that we have here is minus 3. That is minus 3 plus the number of terms that we have is 3 as well. That is 3 minus 1. The common difference we have is 5. I told you earlier, either the common difference or the first term can be negative. It depends on the problems. So now we have T3 equal to minus 3 plus 3 minus 1, and we have 2 or 5. So here we have T3 equal to minus 3 plus 2 multiplied by 5, we are going to have 10. So minus 3 plus 10, we are going to have 7. You can see either they give the problem in form of one problem or in form of a sequence given the series of the numbers. We are still going to follow the same process. So let's take a look at another examples. In some problem, maybe given the first time in which the common difference might not be given. So we follow it the same process, the same pattern. For example, they say given that 5 P Q R 25 are in AP. Calculate Roman figure 1, common difference, Roman figure 2, value of P, Q, and R. Value of P, Q, and R. You can see here is another problem, but it's simple and straightforward. Given that 5 P, Q, R 25 and AP, calculate Roman figure 1, the common difference, Roman figure 2, value of P, Q, and R. So how are we going to go about that? We follow the same process, the same method. We are given 5 P, Q, R, and 25. So meaning here, from this sequence, I can find my first term here. The same approach. Our first term here is going to be 5, right? The first given numbers, just like the way we normally identify it. So our first term is 5. You can see it will be difficult for us to identify our common difference because the second one that we have here is alphabet, not in numbers. I cannot find, if I say P minus 5 now, meaning the second term we have here is alphabet. So if you look at the third one to Q, if you look at the fourth one R, the last term is even 25. That means it will be somehow complicated. So that's how we have to find the common difference first. So now, which means here the common difference is unknown. So now, from these given numbers, can we find the number of terms? Let's check the number of terms here. Let's count the term. These are 1, 2, 3, 4, 5, meaning the number of terms here is equal to 5. Now, I told you sometimes use int term as last term here. So let's check the last term here. The last term that we have here is for 5. For number of terms to be 5, we have it to be 25. You can see when you check the series, when you check the sequence, you can see the last one that we have is 25. So 1, 2, 3, 4, 5. The number of time is 5. At the same time, the last time we have here is 25. So now the first thing that's missing here is the common difference. So that's the first one we have to calculate. So let's apply the general terms, the general formula. We have Tn is equal to a plus n minus 1 d. So let's substitute the values. We have the last term of 5 to be 25. That is 25 is equal to, the first term is 5 plus the number of terms is 5 minus 1. So the difference is unknown, right? So we are looking for the common difference. So now I can have 25 equal to 5 plus 5 minus 1. That's going to be what? Good. That's going to be 4d. So now, since I'm looking for d, I want to collect the like terms so that I can move 5 to this side. So if I collect like terms, that means that we have 25. You can see this one is positive. If the positive come to this side, it's going to become negative. So it's equal to 4d. So 25 minus 5, that's going to be 20 equal to 4d. So I'm looking for d divided by 4 divided by 4. So d is equal to 4 in 20. Of course, you are going to have 5, meaning our common difference is equal to 5. So the second question, we have to find P, Q, R. So our objective here will be which term is P, Q, and R. So if you look at the given numbers, the given terms we have, this is if you count them, this is going to be first term, this is second term, this is third term, this is fourth term, this is fifth term. Meaning the P is the same thing as which term? Exactly. So the P is the same thing as a second term. What about Q? Q is the same thing as what? The third term. What about R? R is the same thing as what? The fourth term. So meaning if I want to find the P now, P is nothing but second term, right? So and we know second term is nothing but A plus D. So if you check our Q as well, the Q is the same thing as which term? That's third term. When the number of term is 3, so that means that one is A plus 2D. Even if I want to find my R2 is the same thing as which term? That's a fourth term, which is A plus 3D. You can see it's very simple and straightforward. So now I've gotten my A. In the problem, we have A already. And at the same time, we have our D. We can easily substitute to get the second term, which is P, and to get the value of Q and the value of R. So if I go by that, so my first term is 5. That is a 5 plus, the common difference that we have here is also 5. It is a 5 plus 5, of course. We are going to have 10. So if you look at the second one, we say Q is the same thing as third term, and that's A plus 2D. So if I substitute, that A is 5 plus 2. My D is 5 as well. So now that means that we have 5 plus 2 times 5. That's going to be 10. Then we have 15. Then if I use this one too as well, my A is 5 plus 3. My D is 5. That means that we have 5 plus 3 times 5. Of course, we are going to have 15. Then that one is going to be 20. So they can give you questions in form of this. So let's take a look at some past question from past questions. How can we approach this AP and GP? Let's take a look at some questions from the past queue. So let's take a look at some questions from here and see how we can make approach of it. How can we solve them? So in some problem, you might be given, maybe asked to find the first terms and the common difference. Maybe when you are solving a problem and you discover that the first term and the common difference is not different, that's when you are going to have an AP. Let's take a look at that before we check some questions from the past queue. In some problem, you might not be given the first term as well the common difference. So if you don't have the first term and you're not given the common difference, mostly it will lead to simultaneous equations. So we have different method of, in our previous video we mentioned how to solve some problem involving simultaneous equations. So now you can use any method of your choice. You can use either elimination method or substitution method, any method of your choice to make it easier. But to make it more better and faster, elimination method is more applicable and is more better. Now let's take a look at this problem. They said the third term of an AP, is 8, while the fourth term is 10. Calculate figure 1 value of common difference and first term, value of common difference and first term, figure 2. Maybe let's say we are asked to find 10th term. You don't need to panic. You see the same process, the same logic of how we solve the other problem. So they said the third term of an AP is 8. How can we write the third term? Do you remember that? Yes, exactly. So third term is nothing but A plus 2D. They said is 8. So A plus 2D is just like they said third term is 8 and the fourth term is 10. Fourth term is 10. So the first one I want to interpret now. That's A plus 2D equal to 8. We can call that one equation 1. So the fourth term, that was A plus 3D equal to 10. This is our equation 2. Are we following? Yes, good. Now you can see how are we calling it equation, because we have two unknowns. You can see I have A as unknown. At the same time, we have D as unknown. So I want to solve this simultaneously. Now, I told you can use any method of your choice. You can use either eliminations, you can use either substitution. But here, let's quickly apply elimination to save our time. So the first equation we are given that A plus 2D equal to 8. And the second one we have is A plus 3D is equal to 10. How are we going to go about that? You can just introduce minus to any equation of your choice, either equation 1 or equation 2, since we are using elimination method. So let's pick one. Let's say introduce minus into equation 1. If I introduce minus into equation 1, meaning I will use minus to multiply all the value we have in equation 1. So that is minus times A, that's going to give us minus A. The second one 2 minus 2D, then we have minus 8. So the second one we didn't introduce minus 2, we have A plus 3D equal to 10. So just have to add them together since we are using elimination method. So you can see minus A plus A, just like minus 2 plus 2, that is 0. So minus A plus A, that's going to be 0. Now, minus 2D plus 3D, of course, what are we going to have? Can we have minus 5D? No, exactly. So minus 2D plus 3D, we are going to have 1D. And 1D is nothing but D equal to minus 8 plus 10, we are going to have 2, meaning our common difference is equal to 2. So now we have gotten the common difference, it remains the first term. You can put this common difference into either equation 1 or equation 2. Either you use 1 or 2, you are going to arrive at the same result for the first term. I will use the 2 so that you can see, are we going to have the same result or we are going to have different results. If I put it in the first one, substitute D into 1. What do we have in equation 1? Equation 1 says that A plus 2D equal to 8. This is our equation 1, because I'm trying to find the value of A. Now, my D is 2, so let's substitute. That means that we have A plus 2 bracket of 2 equal to 8 now. So that means that we have A plus 2 times 2, of course, we are going to have 4 equal to 8. So if I collect like times that we have A is equal to 8 minus 4, that is 8 minus 4. Of course, we are going to have 4. Now, what if I use the second equation? Are we going to have the same result? Let's check if you are going to have the same result. If I check the equation 2, in equation 2 what we have there is A plus 3D equal to 10. So that means that we have a plus 3. What do we get for d? Yes, our d is 2 equal to 10. That's a plus 3 times 2, and we have 6 equal to 10. If I collect like times that we have a is equal to 10 minus 6, then we are going to have a to be equal to 4. You can see that we have the same result. So either you use equation 1 or you use the second equations, you are going to have the same result. Now we have gotten the first question. We have to find the common difference, and we have to find the Fox terms. Now we got our common difference to be 2, and we have our first term to be 4. Now the following problem, we are asked to find the 10th term. Can you guess the 10th term? Yes, that is our 10th term is nothing but a plus 90. So let's go about that. Let's see how we can find that 10th term. When the number of term is 10, that's a tn equal to a plus n minus 1d. We have gotten our a. Our a is 4 from there. We have gotten our d. Our d is 2. So now let's easily find our 10th term now. That means that we have t10 equal to, my Fox term is 4. And we have 4 plus the number of term I'm looking for is 10. 10 minus 1. The common difference we have is 2. So that means that we have t10 is equal to 4 plus 10 minus 1. Of course, we are going to have 92, isn't it? So that means that we have t10 equal to 4 plus, I told you earlier, when we have a bracket, it simply means a multiplication. So 9 times 2, we are going to have 18. So t10 now is going to be 4 plus 18. You are going to have 22. So meaning the 10th term equal to 22. So now let's take a look at some problem from this past Q. They said they are more interesting. We have interesting question from here. In this problem, they said the following are AP sequence, except the following are AP sequences, except we are asked to figure out that which one is not an AP. We might go 1. We said we have 3, 9, 15. Roman 2, 2, 4, 8. Roman figure 3 minus 2, 0, 2. Roman figure 4, 8, 4, and 2. So we are asked to check that which one is not an AP. We should check that they said the following are AP, except that which one out of all this is not an AP. Let's take a look at the first one. Now, if I take the first one, for example, I have 3, 9, and 15. Normally we know this is our first term, this is our second term, and this is our third term. So I will find them using the common difference. So what is the common difference? The one we used earlier. So exactly, that's d is equal to t2 minus t1, or we can have as t3 minus t2. I told you, if it is an AP, the term must have the same difference. So if I check them, let's check this one. Does it have the same difference? Let's check. That's t2 here is 9 here. If I substitute, that means that we have 9 minus 3. Then 9 minus 3 here, of course, we are going to have 6. So if I use the third term and the second term, can we have the same result? So let's check. If I have t3 minus t2, that's 15 minus 9. Do we have the same difference? Yes, of course, we have the same difference. That means the first one satisfies the condition to be an AP. So let's take a look at the second one. We have 2, 4, and 8. Now, you can see this is the first term here. This is the second term, and this is the third term. So let's check if it satisfies the condition of AP. That difference is equal to second term minus first term. So if I substitute, that means that we have 4 minus 2. Of course, that we have 2. Now let's take a look at the second one we have here. If I have third term minus second term, that's 8 minus 4. You can see 8 minus 4 is 4. Is it the same thing as the one we got before? No. So now that means the second one is out of the game. So let's check the we go 3. Is it going to be an AP? What we have there for we've got 3. What we have there is minus 2 is 0 and 2. If I use the same approach, the common difference is a second term minus first term, or I can say common difference is equal to third term minus second term. So that means here I can have common difference equal second term we have here is 0 minus the first term we have here is minus 2. Is minus 2. You can see minus minus, that's going to be what? Plus, exactly. So that means our common difference here is going to be 2. So let's take a look at this one too as well. Third term minus second term. So the third term we have here is 2. Second term we have is 0. So 2 minus 0, of course, we have 2. That means this one to also satisfy the condition to be an AP. Now, if you look at the last one, can that one to also be an AP? So let's check if it's going to be an AP. I have what we have there is 842. You're merely looking, I don't think you can satisfy. Let's check. 8, 4, and 2. This is the first term, the second term, and the third term. So meaning the common difference is second term minus first term. So the second term we have here is 4 minus the first term we have here is 8. So 4 minus 8, of course, we have minus 4. If I need the other one too, as a third term minus second term, meaning if I have 2 minus 4, we are going to have minus 2. Are they the same? Yeah, exactly. They are not the same. So since they are not the same, that means this one is also out of the game. So that means the only one that will satisfy the condition of AP is the first one and the third one. That means the exception here is the second one and the fourth one. So we can still have another problem before we move to some of an AP. Let's take a look if we can have another questions. Let's take a look at some problems. So in some situations, you may be given the terms to be in form of okay, let's look at this. Let's look at these questions. It's a lovely question. Let's look at this. Let's take a look at this. They said find the 20th term of the sequence P plus Q, comma P, comma P minus Q, comma then P minus 2Q. You can see this one is in form of alphabet, not in numbers, but it's just straightforward. You can use the same approach, the same problem. Now, look at it. We have to find the 20th term of this sequence. So the first thing I will do, how can I identify my first term? How can I identify my common difference? That's the first priority here. So if I check, I can label them. This is the first term, this is the second term, this is the third term, and this is the fourth term. You know, I told you, for a term to be a sequence, they must have the same difference. So let's first find our first term here. So our first term here, you can see our first term we have is P plus Q. P plus Q. Then we want to find our common difference. You can find the common difference between n terms. So find if it's just if it's an AP. Now I can take it from here to here. If I said third term, I can say second term minus first term, or I can have third term minus second term, or I can have fourth term minus third term. Of course, they will give you the same results. Either you use the first one or the second one or the third one, they will definitely give the same result. Let's take a look at it from here. So the second term we have here is P minus, so be careful with this because the first term we have here is two values. So the first term we have is P plus Q. So meaning I can have D to be P minus Q. You know, if I use the minus to open the bracket, minus times P, and we have minus P, minus times plus Q, and we have minus Q. So P minus P, that's 0. That means what we have, D is minus Q. So now, or if you like, you can use this one too as well, third term and second term. Let's check that. If you check, can we have the same result? Let's check. So the difference is equal to third term minus second term. So from here, my second term is P minus Q, and the first term is second term we have is P. So now, if you look at it, p minus p, and we have 0. So what we have left is a minus q. You can see we have the same result. So meaning now our common difference is minus what? Minus q. So common difference is minus q. Common difference is minus q. Now the problem says we should find the 20th term. That is when the number of times is equal to 20. Can you recall the general for the 20th term? Yeah, so 20th term is nothing but a plus 19d. But let's show it again. So our general terms of an AP is Tn equal to a plus n minus 1d. So that means that we have T20 is equal to our a is p plus q. I can substitute p plus q plus the number of time that we have is the number of time we are looking for is 20. Is 20 minus 1. The common difference that we have is minus q, just like what we proved earlier. That means that we have T20 equal to p plus q. So 20 minus 1, of course, we have 19, then minus q. So here I can have T20 equal to p plus q. So plus times minus, of course, that's going to be minus. 19 times q, we have 19q. I want to match those who are the same together. That means that we have T20 equal to p plus q minus 19q. Of course, we are going to have minus 18q. So we can have a problem like that. You can have as many problems, just like even in some cases, you'll be given a problem that can lead to a product. So maybe we have 3 terms, or maybe we have 50 terms. We can use the same approach. Let's look at this problem before we move to some of AP. Let's look at this one. The question says that if the sum of 3 consecutive terms of an AP is 15 and their product is 80. Find the first term. And the common difference respectively. So now let's look at this. It's the same approach, the same way of how we solve the first one. If the sum of 3 consecutive terms of an AP, the first term is going to be A. That is just like 3 terms: the first term, second term, and the third term. When we use the word sum, what does that mean? Yeah, if they use the word sum, it simply means to add. And if they use the word product, that one simply means to multiply. If you watch our previous video, we talk about root of quadratics. So we talk about the sum and the product there, what do you mean by sum and what we mean by product. Now, the sum of, the first term is A, the second term is A plus D, and the third term is A plus 2D, because they said the sum of 3 consecutive terms of an AP, the first, the second, as well the third. So their sum is 15. I can say A plus D plus A plus 2D equal to 15, because they say their sum is 15. So let's add the common term together here. A plus A, that's going to be 2A, then plus A, I can have 3A, D plus 2D, I can have 3D equal to 15. So to reduce the term, something is common there. 3 can go, if I divide all of them by 3, that means I can have this one to be A plus D equal to 5. You can call this one as equation 1, right? Now, so they now said why their product is 80. That is the same first, second, third. If their product now is 80, that is, I can have A plus D, A plus 2D if their product is equal to 80. That is, when you multiply all the three terms together, the first one, the second one, the third one, if it is equal to 80, so we can call that one as a equation what? Equation 2. So this we have make the work easier. The first one we have a plus d, a plus 2d, everything is equal to 80. This is our equation 2. So from here you can see we have equation 2. You know, I told you most of the problem, if it involves for you to find the first term and the common difference, mostly it leads to simultaneous equation. But you can see this one, we cannot use elimination there because you can see it involves the product. We have to make use of substitutions. Either you can make either a as the subject from equation 1, or you can make your d as the subject from equation 2. But to make it easier, you can make your d as the subject so that you can easily substitute and evaluate. It can lead to either maybe quadratic, depending on the problem that we are solving. So now, from this equation, I have two equations now. We have two equations. We have two equations now. The first one we have is a plus d equal to 5. This is equation 1. The second one we have is a plus d, a plus 2d equal to 80. This is our equation 2. So now I want to find the value of the first term and I want to find the value of my common difference. So from here, we can make a simple substitution using the substitution method. From equation 1, I can make my d as the subject of the formula if I like, or if I like, I can make my a as the subject of the formula. Anyone you choose, either you choose your a or either you choose your d, you are still going to get the same result. If I make my a as the subject from equation 1, from equation 1, you can pick any one of your choice. You can make a, you can make d, anyone you like. If I make a as the subject, that means I can have a is equal to 5. This is plus d now. So when it comes here, it becomes minus d. So this is my equation 3. While we not applying elimination, you can see it involves the product. So the one we can apply here is a substitution method. So now, this is what we have. This is our equation 3. You can see we make equation 3 from 1. So meaning I will put equation 3 into 2. That is put or substitute the value of equation 3 into 2. Meaning whenever I see the value of a now, my a is the same thing as a 5 minus d. You know, this one we have for equation 2, we have a plus d, a plus 2d, everything is equal to 8. So I want to put the value of equation 3 now. Equation 3 means whenever I see a, my a will be 5 minus d. So now I can have 5 minus d. Second one too, I can have 5 minus d plus d. Here too, I can have 5 minus d plus 2d. Everything is equal to 80. So now here we can have 5 minus d. So here I can have 5, minus d plus d. That's going to be 0. Now, as well, if I have this, I can have this one to be 5 minus d plus 2d. Of course, we can have that one to be d equal to 80, right? So now we can make use of this approach. Now, sorry about that. So now we are trying to make this problem more easier to solve. We have 5 minus d, 5 minus d plus d. I can have that one to be 0. It only remains 5. Then we have 5 minus d plus 2d. I can have that one to be d equal to 80. So if I want to make this one more easier to solve, I can easily divide all through by 5 so that I can redo this time. Divide 2 by 5, divide 2 by 5. So if you do that, let's look at this. If 5 cancel 5, that means that we have 5 minus d, then we have 5 plus d equal to 80 divided by 5. How many 5 can we get in 80? Yes, exactly. We are going to have 16. Now, I can open the bracket. If I open the bracket, that we have 5 times 5, that was going to be 25, right? So 5 times d, we have 5d minus d. Look at it here. 5 times 5, we have 25. 5 times d, I have 5d minus d times 5, we are going to have minus 5d minus times plus, of course, we are going to have minus d times d, and we have d square, everything is equal to 16, just like a simple expansion. Now, here we are going to have 25, 5d minus 5d, that's going to be 0. What we have left is minus d square is equal to 16. So if I correct the like times, I will have minus d square is equal to 16. This is plus 25. When you plot, or you can, if you like, you can bring this one to this side. Let's even do that so that we don't stress ourselves. If you want to collect like times, let the number comes here, let the other one to go the other side. That means that we have 25. This is plus 16. So when it comes here, it's going to become minus 16 is equal to, you can see this is minus d square. When it comes here, it becomes plus d square. So now 25 minus 16, that's going to be what? Yes, exactly. That's going to be 9 is equal to d square. So what we have is d square is equal to 9. So now what we are looking for is d, not d square. What can we use to cancel square? Yeah, square the both side. Very nice. If you square the both side, that means our d is equal to plus or minus over 3. Remember we use that law when we are talking about quadratic, right? Yes, now. So if you missed that video, please subscribe to our channel. Go back to when we talk about quadratic. You can see more examples of how we make use of this approach. So now, the moment we find the square root, that means our d can be positive or negative. That is, our d can be plus 3 or our d can be minus 3, meaning we have two values for d. So now our d can be plus 3 or our d can be minus 3. So now you can put the value of your d into equation 3. Even if you like, you can put it into 1. Anyone, since you have gotten the value of d, you can easily evaluate the value of your a. So put d into 3. What do we have in equation 3? What I have there is a is equal to 5 minus d. This is my equation 3. Write it here. I have a is equal to 5 minus d. This is my equation 3. So I have two values now. So I will use the first one. What is a plus 3 or what is a minus 3? For d to be 3 now. If d is 3, that means that we have a to be equal to 5 minus 3. So meaning my a will be 2, right? Or when d is minus 3, what I have is that a is equal to 5 minus d. So for d to be minus 3, I can have a is equal to 5 minus 3 because the d is negative now. So here we have a is equal to 5 plus 3, meaning my a is equal to 8. So here what we have now is that a can be plus 3 or it can be minus 3 as well. D can be plus 2. The b can be a can be 2 or it can be 8. So now after this we still have what we call sum of an AP, or in some problem you may be given a problem and you may be asked to find let's take a look at this before we go to the sum, if you can find a question related to that. In some problems you may be asked to find x, maybe the terms is like expansion. Let me take a look at these jam questions where we asked to find the value of our unknown, let's say x, or it might be any other alphabet as well. So let's take a look at that. It's jam questions. I think I can find it around here. Now, so let's take a look at this. We are given a problem here to solve, like let's look at the problem. They said if, it's a very interesting question. They said if x plus 1, comma 2x minus 1 and x plus 5 In AP, they say find the value of x. Look at it. You can see all the time that we have here, they are in terms of x, but it's just like a packaging. It's still simple. So you have us here. We can solve this problem using the same approach. We have if x plus 1, the first time, 2x minus 1, and x plus 5, and AP, find the value of x. You can use any approach you like, you can use to solve this problem. But let me just use the how we normally find our common difference to obtain this solution of the condition of AP. If you remember, we said the terms is said to be an AP if they have the same difference. You remember, right? So now I want to use that same approach here to solve this problem now. So if I evaluate them, this is my first term, this is my second term, and this is my third term, right? So I know if I want to find the common difference, I know common difference will surely be second term minus first term, or I can say common difference is equal to third term minus. I can easily use this one. We have many ways of solving it, but I think this is the simplest way of solving this type of problem. Meaning the term must have the same difference. That is, their common difference must be the same, right? The first one, that is our second term minus first term, of course, must be the same thing as our third term minus our second term. So now let's check it here. What do we have on second term here? Exactly. So what we have on second term here is 2x minus 1. That means I can have 2x minus 1 minus what we have for the first time here is x plus 1. We have x plus 1 equal to the third time we have here is x plus 5 minus, so the second time we have here is 2x minus 1. You can see we just make a simple substitution. So now I can have this one to be 2x minus 1. If I open the bracket now, minus times x, what are we going to have? So that is minus x minus times plus 1. That's going to be minus 1 equal to x plus 5 minus times 2x. Of course, I will have minus 2x. Then I will have plus 1. So here, 2x minus x. That's going to be x minus 1 minus 1. That's going to be minus 2 equal to x minus 2x. That's going to be minus x. 5 plus 1, that's going to be 6. So now, if I collect like terms here, I can arrange the terms, that is collection of like terms, the one with x one side, the one without x to the other side. So here I can have x, this is minus x. When it comes here, it becomes plus x is equal to 6. This is minus 2. When it comes here, it becomes plus 2. So here I can have x plus x, we are going to have 2x. 6 plus 2, we are going to have 8. So if you divide all through by 2, so here our x is equal to 4. You can see now what we have for the value of x now is 4. You can use this method to solve many examples. We have many ways of solving it, but I think this is the simplest way of approaching this type of problem. So now let's now go to sum of an AP.